Okay, looks like we have at least 200 participants in, and that was a big portion of those who had pre-registered for the meeting. So I think we can get started. So first, some housekeeping for anyone who needs to use the phone access to the Zoom. We have the phone number and access code listed here, and we'll have this slide available during our QA section. In the question and answers portion, in the Zoom on computer on your phone interface, you could use the raise hand feature or type questions in the Q&A box. If you're on the phone, you can use #2 to raise your hand and *6 to unmute yourself after we select you for your question. Just a brief agenda for today. We're going to have opening remarks from our branch chief Kim, and our section manager for the heavy on-road diesel development, Paul Adnani. And then we're going to have 3 speakers, Daniel Hualti, Shun Nakao, and Mitzi Magtodo. For the topics listed here, after each section or subsection, we'll have a brief Q&A, and at the end, a larger Q&A if we didn't have time in any of the particular sections. So with that introduction, I'll pass it off to Kim and Paul.
Okay, great. Well, I understand we had about 400 people pre-registered for this, so thank you to everyone for joining us. My name is Kim Heroy-Rogalski. I'm Chief of the Mobile Source Regulatory Development branch at CARB. And as folks probably know, CARB worked for many years and then proposed and got approved for adoption our heavy duty Omnibus regulation in summer of 2020. We'd been working closely with EPA on joint demonstration projects for many years, and EPA has just recently followed suit, finalizing their Clean Trucks Plan NOx rule. And so we've been taking a very close look at what EPA finalized, and we have some comparisons that we'd like to share today. And as the staff who are presenting in more detail will be discussing, we definitely understand that many parties are interested in seeing the 2 programs harmonized as much as possible. And so that's, of course, part of the reason why we're digging into the details and impacts of all the provisions in this very big program. So with that, let me see if Paul would like to add any other remarks.
Thank you, Kim. Good afternoon, everyone. My name is Paul Adnani, and I'm the manager of the on-road heavy-duty diesel section. Can we go to the next slide, please? So for today, the workshop is going to be focused on trying to compare some of the elements of the Omnibus regulation and the Clean Trucks Plan. We'll start off by talking a little bit about the different elements of the programs. We'll talk a bit about the differences between the emission standards. And we can then talk a little bit about harmonization and emissions inventory and what kind of impacts are going to be observed through that process. At that stage, we'll take a break and see if there are any questions. Next, we'll talk about the NOx compliance allowance and temperature adjustment, which are the 2 key differences between the 2 regulations. And afterwards, we'll again take a break to address any kind of questions. And finally, we'll talk a bit about Phase 3 greenhouse gas, the upcoming Phase 3 greenhouse gas regulation by EPA. And at the end, we'll have more time to address questions. We understand that our colleagues at the Truck and Engine Manufacturers Association would like to present some information as well. We'll wait till the end of the presentation and answer questions, and then we'll allow them to share they have a number of slides that would be able to share with you guys as well. with that, unless
Actually, Paul, let me hop in, and before we hand it off, let me just add just a little more context, and just to sort of explain why we're spending time in this and why we've scheduled this workshop today. So the Omnibus regulation was one of the largest NOx measures ever developed by CARB, and is really important in helping California attain the health-based ambient air quality standards. It was the largest single NOx measure in our 2016 state implementation plan. And it allows us to lower emissions from California certified trucks, but of course, many of the trucks that drive on California's roads are initially sold outside of California, and therefore are certified nationally instead of with California. And so we're obviously very interested in EPA's rule as well. And we're very happy that EPA chose to do a rule, and we definitely think it will have positive impacts. So with that, let me pass it back to staff to begin the presentation. I think it's going to Daniel.
Okay, thanks, Kim. Thanks, Paul. My name is Daniel Hawalti, and I'm the staff air pollution specialist in CARB, and I work in the on-road heavy-duty diesel section. I'll start with the program elements in the Omnibus regulation. And as you can see, the chart shows a number of elements. You have 8 boxes there, and EPA also has the same elements. Like CTP-NOx rule also has the same elements. Some of them are for new engine certification, and others for in-use compliance requirements. And the CTP-NOx rule or the EPA rule has all the elements except the EWIR, which stands for Emission Warranty Information Reporting Requirements. And that program is a California-only program. Next slide. Okay, comparison of the standards, the EPA, the federal and California standards. The final Omnibus requirements are phased into 2 steps. They start in 2027 and become more stringent in 2031, whereas the federal rule is implemented in a single step beginning in 2027. And some of the federal rule elements are more stringent than the Omnibus, for example, the 2027 requirements. However, in general, the CTP-NOx rule is less stringent than the final or the 2031 Omnibus requirements. Next slide. Okay, the slide shows the 2 key differences between the Omnibus and the EPA's final rule. And the first one is the interim NOx compliance allowance for in-use testing. This provision was introduced in the proposal as a flexibility for the interim period for the heavy-duty diesel engines, and it had a sunset date of model year 2033. The rationale for the provision was to take into account uncertainties that may happen when new emission standards are introduced, and that is to give time to manufacturers during the early years of implementation to refine their products. However, in the final rule, the compliance allowance, although referred as interim, does not have a sunset date. In addition, it also includes medium heavy-duty engines in this provision. And medium heavy-duty engines were not in the proposal, and the public didn't get an opportunity to comment on the inclusion of the medium heavy-duty engines. The second element is ambient temperature adjustment to the Bin 2 off-cycle standards. In this provision, the off-cycle standards increase linearly with ambient temperatures between 25 degrees C and 5 degrees Celsius. And again, this provision was not in the proposal, and therefore the public did not get the opportunity to comment on this element of the CTP either. Next slide, please. This slide depicts pictorially the effects of the compliance allowance and the temperature adjustment on the Bin 2 off-cycle standard. The compliance margin would increase the Bin 2 off-cycle standard from 60 milligrams to 78 milligrams, that is it adds 15 milligrams to the bin 2 off-cycle standard that has also a 1.5 conformity factor on it. On top of this, for ambient temperatures between 25 degrees Celsius and 5 degrees Celsius, an adjustment is added, and the bin 2 standards can vary between 78 milligrams to 122 milligrams, depending on ambient temperatures. Next slide. Now, the question for CARB is whether to harmonize or not. And some background on the harmonization. For the heavy-duty sector, the federal and California emission standards have been aligned since 1991. And manufacturers have been offering the same track platform for sale nationwide. The heavy-duty engine industry prefers to see the same products being offered at the national level, that is continued harmonization. And this is beneficial because it reduces the cost of compliance, and both California and federal tracks would provide the same emission benefits nationwide, making both programs more cost effective. Next slide, please. So the question is, what are the emissions impacts if CARB aligns with the federal rule? Now you can see from the chart, the compliance allowance and the temperature adjustments would reduce expected NOx emissions benefits by up to 4.9 tons per day in 2037. This is compared to a scenario where California aligns with the federal rule, but without the two adjustments. And these risks are significant for California. And there are more than some measures in the state implementation plan. For example, the motorcycle standards that are projected to provide about 2.3 tons per day in 2037. And for another example is a zero emission forklift, and that is projected to provide 1.7 tons per day in 2037. So the emissions impacts are significant. And I will stop here, and if there are any questions on the slides that's the slides that have been presented so far.
Thank you, Daniel. So just as a reminder, you can raise hands or type in questions in the Q&A feature. And if you're on the phone, you could use #2 to raise your hand.
Christian, should I start answering some of the questions that have been typed in?
Sure, go ahead.
Okay, great. First, Matt Spears from Cummins asked, will the potential Omnibus legacy engine revisions discussed at CARB's February 13th Advanced Clean Fleets public workshop be discussed or within the scope of this workshop? And I wanted to respond to Matt. No, this workshop is really specifically focused on comparing Omnibus to EPA's CTP-NOx rule, and specifically, we're interested in showing some comparisons we've done regarding the interim compliance margin and low temperature adjustment. However, of course, as in any of our workshops, attendees are certainly welcome to comment on whatever matters you want to comment on. So if Cummins wishes to speak to that topic, they can. However, I'll just flag that we're trying to, we only have a couple hours, and we're trying to make sure we have full time to talk about the pieces that we came ready to talk about. So we probably won't engage deeply on the legacy engine provisions in this workshop.
Okay, so to answer the question from Larry Robertson, the question is, are you proposing to align for 2024 or just 2027? And we are proposing to align for 2027 because the EPA's program begins in 2027. So alignment would be starting in 2027.
Well, and just to clarify, we're not proposing anything.
We're not proposing, yes, of course, but the discussion is about the 2027 and subsequent model year requirements.
Thanks, Daniel. The next question comes from John Thompson. Related to Eric's previous question, do the harmonization impacts and commonization assume 24 through 2026 or 2024 through 2026 California trucks follow the ARB rule or follow the EPA rule?
Yeah, the emissions impact that I just discussed, for California, they also include the 2024 to 2026 California trucks for California only, and for 2027 and onwards, the assumption is harmonization with the federal rule.
Thanks, Daniel. The next question comes from Gavin McCabe. Is there a breakout of the 4.9 tons per day of NOx emissions between the temperature adjustment and the in-use allowances?
If you can go back to the slide.
Sure.
Yeah.
Is it here? Maybe, sorry, maybe this one.
Hold on. Okay. Okay, so as you can see from the slide, the bar charts, the green one is if CARB harmonizes with the 2027 EPA standards, the benefits would be 12.6 tons per day. And this does not include the impact of compliance allowance and as well as the impact of the temperature adjustment. And the orange chart shows the impact of the compliance allowance, which is about 0.9 or 1 ton per day, which is about approximately 7% of the benefits. And the third chart, which is the yellow one, would indicate that the loss of another 4 tons per day, which is approximately 32% of the benefits. So you have 0.9 tons per day for compliance allowance and 4 tons per day for the temperature adjustment.
Thanks, Daniel. Our next question is from Will Barrett, and Will Barrett, I allowed you to talk. Can you hear us, or?
Yeah, thanks, Christian. Appreciate it. I just want mostly a clarifying question on this, actually, slide 10. The 7% benefit reduction and the 32% benefit reduction, those are simply NOx numbers. There's no lost health benefit analysis being done at this point.
This point, yeah, we haven't done that health benefit analysis. Yes, just
Okay.
the tons NOx benefits.
Thank you. Very helpful.
Yeah.
I'd certainly encourage.
Yeah, we will be working on it. Yeah.
Okay, thank you.
Yeah.
Thank you, Will. Thanks, Daniel. The next question comes from Colby Morrow. Would you clarify the difference between the Omnibus 2027 and EPA 2027? As I heard, EPA is a bit lower.
I can
Okay,
I answer that question. If you go to the backup slides in the slide deck, there are so there's one here for light heavy duty engines, and I won't spend too much time on this, but we've broken it down by primary intended service classes for the engines. This one is for light heavy duty engines. The orange boxes are the Clean Trucks plan numbers. The green boxes are the Omnibus numbers. Dark green is from 27 to 2030, and light green is 2031 and subsequent model year. So these are what we call stringency charts. On the left-hand side, you will see the columns it says least stringent, and on the right-hand side, it says most stringent. So you can look at the different elements and you can sort of compare stringency between the two regulations. But there's 3 of them here, one for light heavy duty engines. Well, let me just read one row so you can perhaps see it. So for example, idle NOx standards, it's 10 grams per hour under the Clean Trucks plan. So we put that on the least stringent side. The Omnibus requirement for 27 and subsequent model years is 5 grams per hour. So those are more stringent. So in these charts, you can sort of compare to see which element is more stringent than the other one. And as I mentioned, there's one for light heavy, one for medium heavy, and one for heavy heavy. Okay, we
Okay,
can go to the next
Thank you.
question.
the next question comes from Richard Rikowaski. EPA referred to the cold temperature NOx emission data when they justified the in-use temperature adjustment. Does ARB have data that indicates EPA's temperature adjustment is too large or not needed?
I'll answer that one too. We will go into some more technical analysis of that in the next part of the presentation.
Okay, our next question comes from Lacey Robertson. Would you still implement a 0.05 standard in 2024?
Kim, would you like to say anything to that regard?
Sure, if I can manage to get my camera back on. Yeah. So first of all, we're not proposing anything specific regarding how CARB might or might not, align with parts of the federal rule here. We're just sort of showing you some of our real-time thinking as we consider what we're going to propose there. And as I think Daniel explained, the federal program only takes effect with model year 2027. Omnibus, on the other hand, begins with model year 2024. And so we're not contemplating any changes to the Omnibus model year 2024 to 2026 standards.
Thank you, Kim. The next question is from Sam Wilson. Similar to William's question earlier, when staff looks into the health benefits and losses from harmonization, do you plan to look at how these losses will be distributed among the population, i.e., which population would be impacted the most from the benefit losses?
We haven't looked yet at the health benefits or health impacts from the losses in this, which may result from harmonization. And we haven't looked at the distribution. But as we know that heavy-duty trucks operate mainly in the disadvantaged communities, like near the ports and other places too, and where you have warehouses and other things. And therefore, we think that the impact would be more on the disadvantaged communities.
Thanks, Daniel. Our next question comes from Tim French. CARB's estimation of 4.9 tons per day decrement seems high. Can you share the MFAC modeling from which that estimate is derived? For context, the 2020 mobile source strategy estimates that the NOx reduction benefits from both the Omnibus and ACT will be 7 tons per day in the South Coast as of 2031. So again, the 4.9 estimate seems very high. We would very much like the opportunity to review that work. It would also seem to assume incorrectly that OEMs will design to the in-use allowances as opposed to the standards, as that's not how it works. ACD provisions would prevent that in any event. So yet again, the 4.9 tons per day number warrants a thorough review.
Mm-hmm. Hello, this is Sarah Forestieri, and I manage the on-road model development section. And yeah, we know that the emissions inventory piece of this conversation is very key, and we're happy to talk more offline about the details, but just kind of real quickly, the mobile source strategy used MFAC 2017, and the current modeling is based on MFAC 2021 and accounts for the heavy duty inspection and maintenance program. So there's kind of that nuance there. But in addition, let's see. So you're calling out numbers in 2031, and what we showed today was in 2037. In 2037, a much larger portion of the fleet will have model year 2027 or 2024 and newer. So basically the impact of like CTP or Omnibus regulation is much greater in that year. So that's why you're seeing a bigger number there. And then in our experience with 0.2 certified diesels, the diesel vehicles that we've seen in our in-use testing programs emit 2 to 3 times greater than their certification standards. So we think the in-use testing piece is extremely important for understanding like where the actual in-use or real-world emissions are going to end up in our modeling. But yeah, obviously, we're very happy to follow up offline.
Yeah, I kind of want to address the latter portion of Tim's question, where it says it would also mean incorrectly that OEMs will design with the inclusion of the in-use allowances. The fact of the matter is, and it's in the case today too, when they do in-use testing, is if you have an allowance that will be added to the standard and you compare the emissions from the vehicle relative to that number. So the allowance is there. It will be something, a cushion on top of the standard. That's the practice today. That will be the practice in future. In terms of AECDs, I honestly don't know how that is related to this discussion. I think if EMA or its members would like to discuss EACDs, I think that would be a separate topic that we could address later. Thanks.
Okay, thank you, Sarah, and thank you, Paul. I don't see any new questions, and in the interest of time, we should move on to our next presenter, Shun Nikal, to talk about the compliance, some topics on compliance allowance now.
Right. Excuse me. Thanks, Christian. So as my colleague Daniel mentioned, the EPA's Clean Trucks Plan, NOx rule, includes interim compliance allowance that has no sunset. This compliance allowance is applicable to medium heavy-duty engines and heavy-duty engines. And 15 milligram per horsepower hour is added to the in-use FTP, SET, LLC, into off-cycle NOx standards. And the purpose of this compliance allowance is to account for potential variations, either positive or negative, or potential positive bias that may exist in in-use engines, but not in the laboratory certification test engines. And to calculate this compliance allowance, USMP consider these 5 factors. Each of these factors are described in regulatory impact analysis document, so we wouldn't go into detail of each of these items, but within these 5, the last one, field aging, was the biggest contributor. So we are going to discuss this further in the next few slides. Next slide, please. So this intent of this field aging is to account for potentially more severe aging that happens in in-use engines more than the laboratory certification engines. And then these are the sub factors that that contribute to this field aging. The first one is the long-term impact of a more severe duty cycle that might require more diesel particulate filter regenerations. And then the second is the impact of fuel impurities. And then the last one is the impact of other engine-related issues, such as exhaust gas recirculation cooler leak that was too small to detect, or the impact of a short-term high-temperature excursion results from a turbocharger failure prior to fault detection, etc. So basically, these are hardware failures that are too small to detect, but significant enough to contribute increase in emission that only exist in in-use engines. And regarding the first point, severe duty cycle and DPF regenerations, for medium heavy duty engines, the NOx standards were derived from emission data of a heavy duty engine at 650,000 miles, whereas the regulatory useful life of medium heavy duty engine is 350,000 miles. The justification for this 300,000 miles extra aging is that the medium heavy duty engines encounter more severe duty cycle and hence more DPS regenerations compared to heavy duty engines. Therefore, this more severe duty cycle is already accounted for when determining this aging requirement. And then second point is that for, could you go back to this? For heavy duty engines, laboratory aging up to 750,000 miles is required, whereas the regulatory useful life is 650,000 miles. And then this extra 100,000 miles is to provide a cushion for additional deterioration from field aging. And again, severe duty cycles already accounted for in development of the 35 and 50 milligram per horsepower hour FTP, RMC, and LLC standards respectively. So we think adding field aging component for in-use compliance allowance could be seen as double counting. And then also heavy duty in-use testing or HDIUT program allows for screening out of vehicle with atypical operation that includes severe duty cycle. Next slide, please. So this is the actual language regarding how the screening process works. I wouldn't read the whole thing, but these criteria ensure that the vehicles are properly maintained and used, and engines have not been tampered with, rebuilt, or undergone major repair that could be expected to affect emissions, and the engines have not been misfueled. And also manufacturers can screen up vehicles and if the usage is atypical for the particular application. Next slide. And regarding fuel impurities, again, HDIUT includes a screen up process, and manufacturer can screen out vehicle based on their criteria. And then if vehicle is misfueled, the vehicles can be screened out. And regarding hardware failures, it's unclear why additional allowance is needed for hardware scenarios. All emission-related components must be durable to full useful life, and potential failure due to poor design or bad components should not be used as a justification to relax the standards via compliance allowance. So, in other words, if the failure is due to poor design or bad components, we think that is a legitimate failed test, and that should not be a reason to relax the standard. And again, there is a screen out criteria for poorly maintained vehicles. Next slide, please. And regarding statistical analysis, or more specifically variance and mean, each compliance allowance input, namely sulfation or fuel or field aging factors, etc., they all contribute via a variance term that was calculated based on a single engine test. So the final compliance allowance of 15 milligram per horsepower hour was only based on results for single engine test and only applies to single engine test. However, the HDIUT pass-fail criteria is based on the average of 10 engine tests per engine family. And the single engine failure would not make an engine family non-compliant. So compliance allowance needs to consider a sample size of 10 engines, since that's the only way to fail. That's the only failure mode. And we think it's important because allowance calculated with the sample size of 10 engine would be much smaller because the variance of single test cancel out. And then I'm moving on to the next flowchart. So this is the procedure in HDIUT pass-fail determination. And I wouldn't walk through the whole flowchart. And here I want to point out that there are 3 ways to pass, but there is only 1 way to fail. That is, you test 10 engines and then calculate arithmetic mean of 10 engine tests. And then if the arithmetic mean is greater than the standard, then engine family fails. And that's the only way to fail. Now, therefore, we think it's important to consider 10 engine tests. And again, that will decrease the size of the variations because the variation of each test cancels out when you think about mean of 10 tests. Next slide, please. So here are the takeaway points about compliance allowance. First of all, calling a provision interim implies that there is a sunset date. And then second, considering failure scenario and accounting for sample size of 10 engine tests would reduce the calculated allowance, again, because of single variance of single engine test cancels out. And OEMs already can screen out well-maintained or misfueled vehicles from HDIUT program, and which already account for the issues used to justify the field aging component. And with that, this is the end of this section of the presentation.
Thank you, Shen. So like before, the Q&A part is open for this section. You can type questions in the Q&A box or raise your hand. Okay, we have our first question from Steve Berry. On slide 14, why do you state severe duty cycle already accounts for in development of 35 and 50 milligram per horsepower hour FTP/RMC and LLC standards respectively? Do you
Yeah, go ahead.
Do you consider Southwest's DAC aging process as applied in the demonstration was severe? So I can go back to
so let's go back to the let's flipping back. Okay, yeah, okay. So to answer that question, no, we do not think that the DAC aging process is considered as severe. We think that DAC aging was done, and there's an emissions test point at 350,000 miles, which is the useful life of a medium heavy duty engine. Now, that's not what was done by EPA. They took the emission test point at 650,000 miles. So they already added a cushion on top of the useful life emissions when they established the 35 milligram number. Then on top of that, they added another 15 milligram due to compliance allowance. So to us, that is a double counting. You know, they could have taken the 350,000 mile emissions test point and then say, okay, we need a cushion on top of that. But it appears to us that there's a double counting here. They went to look at the emissions data point at 650, which does not correspond to the useful life of a medium heavy duty engine.
Thank you, Paul. Okay, we have another question from Chris Mays. Did the DAC aging consider engine component aging or only after treatment aging? If not engine aging, please can you explain how accounting for wear is taken into account?
So I think the DAC process is focused on the after treatment aging only. It includes thermal aging and chemical aging. Within the EPA process, they have a process to sort of accept that aging. Within the CARB regulation, the durability requirements is more complex. So for CARB, we have a portion of the useful life that needs to be the whole engine and the after treatment system would need to be aged on a dynamometer. So if there are any kind of interactions between the upstream components and downstream one, those will be taken into account. And then a portion of it will be based on DAC aging. I believe the latest version of the Clean Trucks Plan also has that option. So the manufacturer would need to age, and I don't remember the exact number of hours. It's over, maybe it's around 1,500 hours or so. That needs to be done on a dynamometer, and the rest of it will be done using DAC aging.
Thank you, Paul. Currently, we don't have any new questions coming in. So at the end of the presentation later, if there's not time right now, you can ask questions related to any of the three or four major topics we're discussing now. So we'll move on to the next topic, which is temperature adjustments from Shunigan.
Okay, sorry, switching gears to temperature adjustment. Just US EPA introduced the adjustment to the off-cycle NOx standards based on EMA sponsored test at Southwest Research Institute. We call it low ambient temperature testing with wind simulation. The objective of the test was to simulate actual truck operations on the road in cold ambient conditions where there's always wind around the after treatment when trucks are running. That temperature was reduced to around 2 to 9 degrees C. And then they used a variable speed blower to blow cold lab air over the after treatment system. The airspeed over the after treatment system was set as some constant fraction of the instantaneous vehicle speed. And this fraction is less than 100% to account for some level of protection of the after treatment from the full speed of wind by some vehicle components. Next slide, please. So in the low ambient temperature test with wind, they observed significantly greater VIN2 emission, which was 87 milligram per horsepower hour, compared to their reference test conducted at room temperature around 25 C, which was 47 milligram per horsepower hour. So this increase in emission was due to cooling of exhaust gas temperature, which led to loss of catalytic efficiency. And then it increased tailpipe NOx emissions. And based on this simulation or experiment, EPA introduced a temperature adjustment function, which linearly increased the standard as a function of temperature from 25 degrees C or below 25 degrees C. So at 25 degrees C, the standard is 78 milligram per horsepower hour, and it linearly increases to 122 milligram per horsepower hour at 5 degrees C. And this is 44 milligram per horsepower hour increase or 56% increase. Next slide, please. So I'd like to share some relevant facts regarding the temperature adjustment. So although the low ambient temperature test observed high emissions, countermeasures can be taken with the stage 3 engine to correct for the ambient temperature fluctuations. But unfortunately, the project scope did not include investigation of these countermeasures. And HDIUT data from actual truck operations by several manufacturers on the road do not show exhaust temperature cooling in more cooling in cold days than in warmer days. And CARB has 16 years of experience in analyzing in-use test data from real-world trucks and testing trucks in-house. And FTP, RMC, LLC standards do not have a temperature adjustment function between temperature range 20 and 30. And keep in mind that the low ambient temperature adjustment applies below 25 degrees C. And the temperature adjustment does not exist in the current NT protocol and in-use test protocols. Next slide. So the temperature adjustment assumes lower exhaust temperatures at colder ambient temperatures. However, again, we do not see that kind of correlation in use in real world HDIUT data. So upper plot shows, these plots show the example from one test, and upper plot shows the exhaust temperature and engine power versus test time. And then lower plot shows the corresponding ambient temperatures. The dotted lines overlays some of the peak exhaust gas temperatures. And the maximum exhaust gas temperature was observed around 340 minutes. And its maximum temperature is noted as T here. And when the maximum temperature was observed, the corresponding ambient temperature was just 1 degree C. So in other words, the highest exhaust temperature did not occur when the ambient temperature was the highest. And generally, as you can see, the relationship between this peak temperature and then ambient temperature seems random. So instead, the exhaust gas temperature tracked engine power, as you can expect. When power goes up, exhaust temperature goes up, and when power goes down, exhaust temperature goes down. Next slide, please. So as we saw in the previous slide, the exhaust gas temperature strongly depends on power or duty cycle. So, and as you can see here, it has a large variability. And the previous example was just one data point. And in order to see more global relationship, we combined the result from 5 tests. In the temperature adjustment, the temperature adjustment assumes 30 to 50 degrees C reduction in selective catalytic reduction temperature, 2 to 9 degrees C ambient temperature compared to room temperature 25 C. So this means a positive slope of around 1.5 to 2.5 in exhaust temperature versus ambient temperature. And the observed trends are not consistent with this assumption, as you can see in the upper plots, the exhaust temperature versus ambient temperature. The exhaust temperature values is removed to protect OEM confidentiality. And since exhaust gas temperature did not depend on ambient temperature or did not correlate with ambient temperature, it's not surprising that the corresponding brake-specific NOx emission also did not correlate with ambient temperature. Next slide, please. So, again, the duty cycle plays a major role have a major impact on exhaust gas temperature. So in order to eliminate the impact of exhaust gas temperature, in this slide, we looked at the different kinds of tests. In this test, the same vehicle was tested on the same route, but at different temperature, so that we can eliminate the impact of duty cycles. So in the upper plots, as you can see, one test was generally consistently lower or colder than the other test by a few degrees C or up to around 7 degrees C. And then the lower plot shows the exhaust temperature versus time. So as you can see, there is no consistent trend. Sometimes exhaust temperature, gas temperature is lower on cold day, or sometimes it's even high. Even exhaust temperature of cold test was higher. Sometimes higher in warmer day, or sometimes higher in colder day. So again, this data is not consistent with the assumption of the temperature adjustment. So in conclusion, in a real world, the after treatment does not seem to cool off any faster in lower ambient temperature within 5 to 25 C. So this observation is very different from the premise of temperature adjustment. And that's the end of this section.
Thank you, Shun. Okay, we're going to open up again for Q&A.
Yeah.
We already have questions in,
Yeah.
and did you have something to say, Paul?
Yeah, I can answer the questions.
Okay.
So the first one says CARB slide says HGIUT allows for screening out of the vehicles with atypical operations or severe duty cycle according to 40 CFR 1036-410. But the aging encountered by medium heavy duty engine systems in vocational applications doesn't fit this atypical operation criteria. And that's very well true, but you have to bear in mind OEMs, when they design their engines, they're responsible for looking at the typical operation of the truck and design their hardware and their software accordingly. So if you know your medium heavy duty engine is going to encounter more vocational operations, you know, the hardware needs to be able to handle that. That's just part of your design. We don't understand why you would use a 650,000 mile emission test point for a 350,000 mile truck. Your truck needs to be designed to meet the operations that it encounters in the field. Steve Berry has the next question on slide 24. It's unreasonable.
Can you hear me?
Yes, Abraham.
I'm sorry. I have one additional comment on that CAS question.
Sure.
So if you, Christian, I'm sorry, but if you go to the slide 12.
Slide 12, sure.
No, that's not 12, I think. So CFR 1036-410 slides. Oh, I'm sorry, but yeah, go down one more.
Okay.
So in that, if you see this regulation in 1036-410C, it said that basically if you have any region, something like you think this is a typical, like that kind of situation happening, but we now doing the normal operation for the testing. If you tell us, or EPA or CARB, then we can make an adjustment, or even we can allow them to reject that kind of vehicle. That's what I want to add. Thank you.
Thank you, Abraham. We'll continue with the question from Steve Berry, related to slide 24 here. Is it reasonable to use a macro scale plot such as these to judge whether the ambient temperature is influencing exhaust temperature, especially under such a high level of variation and transients in the engine torque trace? Can one really make any judgment at all from the data presented, especially when the upper graph vertically scale is 10x of the lower scale?
Okay, we've tried to get more information from the data that was submitted to EPA, but by EMA on this topic. Unfortunately, when I go to the docket center, it's marked as copyrighted material. And they told me the only way I can have access is to go to the docket center and take a look at it. If EMA would like to discuss this matter further, I would recommend that they take their data from their low ambient temperature testing and plot it on the same sort of macro scale. And if they would share that data with us, we would like to have that conversation with them. Then we can see if there's sort of a trend, that the trends look the same, or if there's no trends that could be seen. In terms of the next questions, plot presented without scales, yes, that's correct. We try to treat this information as confidential information, so we're not showing the actual numbers on the scale. I think, if I'm not mistaken, up until a few years ago, at least I remember, EPA actually used to post the HDIUT data on their website. So you might be able to access the data through that way. What are the general comments?
I can take this next one.
Okay.
So Nicole Rice asks, so what are the general conclusions that CARB has come to based on all this data comparison? And what is it that CARB wants the regulated community to take away? I guess sort of as the takeaway message here. And yeah, we definitely recognize when you dig into the details of these provisions and the justification for these provisions, it's highly technical and there's a lot of detail here. So our main point and the reason that we held this workshop is to make clear that the interim compliance margin and low temperature adjustment have major impacts on the emission benefits achieved by the CTP-NOx rule. Our technical experts have dug into the rationale for those provisions and don't believe they're well supported by the data. So that is something significant that staff and the board will need to keep in mind as we consider to what extent CARB can align with the CTP-NOx rule for model year 27 and forward.
Thank you, Kim. Steve Berry has a question on slide 25. The upper graph, isn't it true that the exhaust temperature during the course of an increasing ambient temperature would much more heavily be influenced by engine power? Was the average engine power controlled over the course of the ambient temperature excursion?
Okay, so I can address that. From what I have seen from the Southwest research data, Steve, your maximum temperature is always going to be encountered at the highest ambient temperature. Christian, go to the next slide on 26. So you look at this data and you look at, sometimes you see the black lines are above the gray lines, and sometimes on the exhaust temperatures, the gray lines are above the black lines. There doesn't seem to be a consistent correlation between the ambient temperature and the exhaust temperature. If you look at the same chart from the Southwest data, you will always see it's always, there's one line that 25 degrees C line is always above the 5 degrees C line. So we can talk, I think part of the issue is that this is a very important, uncontroversial technical issue. And I think, we just didn't have the proper time to have these discussions, with the stakeholders to talk about this. But we would be more than happy to talk with you more about what we have found and what was observed in the low ambient temperature test. Next question.
Sure, thanks, Paul. The next question comes from Alex Bosenberg. What the in-use temperature data test day done only with one vehicle or with a fleet of varying sizes and designs?
Okay, so the ones that I showed you are the ones that Sean showed you are data from 2 different OEMs. We also have data from a third OEM, and all of them show the same trend. There's no correlation between within this temperature band of 25 degrees C to 5 degrees C. We don't see any correlation between exhaust temperature and ambient temperature. Okay.
Thanks. Steve Bear has a comment. EMA is not limiting the availability of the data. So that
Okay,
sounds-
well, we look forward to receiving that report that was submitted to EPA, and we'd be more than happy to talk with you guys.
Our next question comes from Gavin McCabe. Does the omnibus rule give any allowance for emissions in the extreme cold? Relatedly, would EPA rule be more consistent with omnibus rule if the upper end of the temperature range would be decreased? If yes, how long would it need to go?
So within the omnibus regulation, there's a temperature cutoff. And Christian, you may have to help me with this one. Is it -7 degrees C?
Yeah, that's right.
Right. So within the omnibus regulation, there is no correction factor for ambient temperature. But once you hit -8 degrees C, there's, your in-use testing would basically be invalid. Now that's sort of identical to what's done in the European Union. And no, we don't have any allowances for cold ambient temperatures in our omnibus regulation.
Thanks, Paul. Next question comes from Bill McGavern, or actually it's a comment. The 4.9 tons per day is a lot of NOx, and California cannot afford to give up that amount of emission reductions.
Thank you. We appreciate it. We're well aware of it too.
And the next question comes from Elena Gienko. How is the analysis relate to the adoption of ACF regulation?
So I think that if you have to go back to the emissions chart that Daniel showed, Christian,
Sure.
I think that one, those numbers included, let me yeah, and Daniel, you could perhaps help me with this, but I think this included the impacts of the ACF scenario that's provided in the initial statement of reason.
Yes, that's correct. Yeah.
The basic thing is that we know ACF is coming. It's not fully adopted through the board yet, but we weren't sandbagging these numbers to make them look even larger when we know that rule is coming. So that's, we folded in the reasonable assumptions based on what the board direction we'd received. And so those ZEVs would displace some ICE engines. And so we're not counting ICE engines that we expect to be ZEV displaced.
And just as further context there, by ACF, we mean the Advanced Clean Fleets Regulation, which the board has considered at one board meeting and will vote on at the upcoming April board meeting. And that's a requirement for large fleets in California to purchase zero emission heavy duty vehicles. So it affects some of the same population of trucks as the Omnibus and CTP-NOx rule. And so that's why we noted on that chart what we were assuming for it.
Kim, would you like to respond to that last question too?
The last question comes from Stacy Hammond. In 2024 standard is not change. What do the California fleet owners do if they need to purchase equipment now and OEMs do not have available approved tech to purchase?
Yeah, thank you for the question. Our certification folks have been working closely as manufacturers work out their plans for complying with the Omnibus standards. And we can't talk in detail about what those plans are, but we are aware that the manufacturers are planning to bring to market compliant product. There may be, of course, the Omnibus standards do reflect a change in the standards, and the manufacturers have to do work to meet those, and they have to factor in the fact that there's federal standards coming just a few years later. So we are aware that some manufacturers are planning on changing or limiting their product selection in California for the years 24 to 26. And so we're looking closely at that issue and considering whether there's any need to tweak the transition provisions that already exist in Omnibus. When we adopted Omnibus, we were aware that it would be a challenge. It's an aggressive rule. And so we built in some provisions called the legacy provisions to help manufacturers smoothly transition to meeting the new standards and try to limit any shortages of products. And so we built in some provisions where a manufacturer can continue to make engines that meet the older standards, meet today's 0.2 gram standard. We call those legacy engines. And we built in provisions where a manufacturer can choose to make those legacy engines as long as they offset the emission increases that result. And so we're taking a close look right now as we work with each of the manufacturers and understand the current status of their plans for certifying to Omnibus to see if there's any need to tweak those legacy engine provisions. And we have been talking about possibly tweaking those provisions in the context of the Advanced Clean Fleets regulation that's going to the board for consideration next month. But that's still to be determined, but we're aware of the issue and we're working to address it.
Thanks, Kim. Our next question comes from Kat Lacker. Is the right column on slide 10 assuming that these vehicles are operating in use constantly at 5 degrees C? Questioning the reality of that assumption and seeking clarification if there are plans to adjust this based on the normal temperatures in California.
I'll take that one. That's an actually excellent question. Christian, can we go to that backup slide on the ambient temperatures in the South Coast region?
Sure.
Yeah. As a sort of an introduction, I want to say that since this temperature adjustment data came up, we heard from some stakeholders telling us, hey, look, South Coast, ozone is only an issue in hot days at summertime. What do you even care about this temperature adjustment? This shouldn't impact you. And I think the problem is a bit more nuanced and complicated than that. Here in this chart, what we have are the monthly average temperatures in South Coast. The red line is the average morning temperature, and the blue line is the average evening temperature. Now, sure enough, if you look at July and August and September, in the mornings, temperatures are above 25 degrees. So the temperature adjustment doesn't come into play. But in the same summer months, if you look at the evening temperatures, you do see them being below 25 degrees C. So we reached out to our inventory folks to look at VMTs in the evenings. And it turns out that around 40% of the heavy duty VMT happens between the hours of 8 p.m. and 8 a.m. So, this is a more complicated scenario to analyze. Our inventory group is already sort of looking at that because you have to look at, in reality, daily temperatures in different regions, and you have to look at the VMT in the morning, and you have to look at the VMT in the evenings. It's simplifying this as saying is the average, monthly temperature, at summertime is above 25. That's not true. The temperature fluctuates in the morning and the evening. So this temperature adjustment will have an impact during the summer months. How much of an impact it's going to have, we don't have an answer for you. That's something that will be done as part of the MFAC development. Next.
Thank you, Paul. The next question comes from Eric Feely. Oh, I'm sorry. Actually, I think first Abraham and the next Bill would probably like to comment. more on the previous question.
Yes, can you hear me?
Yeah, we can hear you, Abraham.
Okay, this is Abraham, by the way. I'm a lead staff for the HDIoT program at CARB in Heavy Duty News Compliance section. And I got a lot of data coming from in-use testing. And then in addition to what Paul says about those test in-use emission, a lot of testing is conducted during the early morning or even after afternoon or evening, and some of them is taken during overnight. So my understanding is because of testing would not hinder their fleet's normal operation. So what I'm trying to say is that emission test data coming from HDIT program is not tested during the cold temperature reason. Thank you.
Thanks, Abraham. Bill, did you have a additional comment?
Yeah, I just wanted to comment on the, this, what's the right temperature to think about, or distribution of temperatures. And, of course, those vary spatially as well as by time of day and season. So we tried to have at least a couple of data points that help people understand the span of it. And so that original bar chart in the first presentation, there's the tallest one, and then there's the one with the measurement allowances applied, and then there's the measurement and the 5 degrees C applied. So you can look at the middle bar as being 25 degrees C, and the smallest one as being the 5 degrees C. So whatever your mix of preferred assumptions for averaging temperature or applying this linear correction to a distribution of temperatures, you've pegged the two ends of the effect with that middle bar and the right bar. So I just wanted to point out that I'm not sure we had it labeled up as a 25 degrees C bar, but that's how you can view that middle bar. So it's going to be somewhere between those two limiting cases.
Thank you, Bill. Going back, Eric Feely had a comment here. It would be nice to see the fraction of that 4.9 tons per day attributed to the ACF ISOR broken out, as well as the 2024 to 2026 portion of the Omnibus rules, if that's possible. Our next question comes from Yusuf Khan. The Southwest Research Institute study was on the low NOx engine with a dual SCR with a lot more surface area. And your data probably collected on a 0.2 gram per brake horsepower hour. So could it be possible that the slight impact on temperature profiles may lead to some increase in NOx?
So here's what we know. We looked at exhaust temperature data, and we don't see any correlation between ambient temperature and exhaust temperature. These are for current systems where under the truck chassis, you have a DOC, a DPF, and an SCR. For the Southwest Research Stage 3 engine, if it goes under the truck, it will be a DOC, a DPF, and an SCR. Now, we also know that based on information from Southwest, there are countermeasures that could be taken to ensure that the exhaust temperature does not vary. So I think there's possibility there. One thing we know is at least these trucks from 3 different OEMs that we looked at, they did not show any impact of ambient temperature on the exhaust temperature. Next question.
Sure, thank you, Paul. The next question comes from Stacy Hammond. Thank you for the follow-up. Will the legacy vehicles count in the ACF tech, not available option? And will they have a clean idle decals?
I honestly, we're not, this is not the folks who do the ACF rulemaking are not here, and we're not comfortable making any statements related to the ACF rulemaking here. And the purpose of this workshop is not to look at the ACF rule either.
Thanks, Paul. The next question is from Lacey Robertson. What is California's process for verifying CARB engine certification when registering a new truck with with California's DMV? In 2024, how will the DMV prevent trucks with EPA only certified engines that are not able to be registered in California?
So, and I'm not an expert on this, but I used to work in the certification group, and we do issue executive orders for heavy duty engines, and they go to BAR and they go to DMV. So there is a process to look at what's certified in California. So if you go in with wanting to register a new truck, I believe DMV has a process to check to see if the engine there is California certified or not. And if it's not California certified, they won't register it as a new truck.
Okay, thank you, Paul.
There already, even currently, there are some models of heavy duty engines that are only what we call 49 states certified. And, on the label on the engine, it clearly says that, this is only for US, certified by US EPA. If it's certified in California, the ECI label, the engine label on it, it would say this engine is certified in California, it's certified by California and US EPA. So there's a mechanism to check that.
Thank you. Our next question comes from John Gorgal. Due to the expected price increase for the Omnibus compliant vehicles relative to the federal compliant vehicles, are you planning to estimate the emission benefit due to the slower fleet turnover?
Christian, you might be the best person to answer this. We did some sensitivity analysis when we did the Omnibus regulation to look at the cost of engine on fleet turnover. Christian, do you remember anything?
Does anybody else? Well, between the Omnibus and the Clean Trucks program rule, the technology package required to meet the regulation, it is no different. Same technology is used in both. So in terms of technology, there's no difference between the two. So, federal or the California, the way we have it now. So we don't expect any additional slower fleet turnover from that perspective.
Yeah, we did a sensitivity analysis, I think, when we did the Omnibus regulation to look at that, if I'm not mistaken.
We did do a sensitivity analysis during our Omnibus rulemaking, and we did estimate the impacts from slower fleet turnovers, or from that could be from possibly owners holding their equipment for longer periods of time, and also pre-buying their vehicles. But the main messaging from that is that the health benefits and the NOx reduction is still very important, and that's why we had to go forward with our Omnibus rulemaking.
Okay.
Steve Barry has a comment to what Bill was mentioning earlier. So the rightmost bar is built on the assumption of the 5 degrees C ambient for all operation. Maybe they're talking about slide 10.
Can we go back to that slide? Yes, that is correct. The yellow bar assumes all operations is at 5 degrees C. So the actual number is going to be somewhere between the orange and the yellow bar per adjusting the MFAC model and figuring out, how much nighttime VMT, how much morning VMT. It'll be some number between the two. And that analysis has not been done yet. That's going to be a sort of a bigger analysis to modify the NFAC model.
Thanks, Paul. The next question comes from Ken Presley. Has any consideration been given to EPA's modified D-rate schedule and the positive impact it will have on reduced emissions?
I'm not sure what D-rate schedule he's referring to. I don't know if this is referring to the inducements. If you could perhaps clarify that, your question, we can respond to it later.
Okay. The next one comes from Tim French. This is a follow-up on Paul's point about nighttime temperatures and heavy-duty on-highway VMT. Does ozone from does ozone from at night without sunlight?
Okay, so ozone, no, does not form, but the NOx emitted at nighttime magically doesn't disappear by the next morning. Okay, so the analysis needs to be done. The nighttime NOx will be emitted. It will be in the atmosphere. It has a half-life. It will be there, and what kind of an impact it's going to have on ozone, that would need to be determined.
Yeah, and I'd add that we have strong temperature inversions that cap the airflow and limit the vertical mixing over the South Coast Basin and over the San Joaquin Valley. And, it's where a lot of our truck activity is, and it's where a lot of our population is. So both of those regions, will see significant daytime effects from overnight emissions.
I'm still don't understand the model year 2027 D-rate schedule. I'm sorry, Ken. If you have perhaps a regulatory citation that you could share with us, we can go look at that. I'm not sure what you're referring to.
But if you are referring to EPA's changes to inducements, we have included the whole program in our modeling. So it's not like there's some additional benefits that we didn't model. Also, I think Susan O'Connor had an answer to a previous question regarding clean idle labels. Susan?
Yes, hi, Kim. This is Susan O'Connor. I'm in Paul's on-road heavy-duty diesel section. Christian, could you ask that question again so that it's clear for what I'm answering?
Let me go look through the questions.
The question was, will California Omnibus legacy engines have clean idle labels? It was from Stacy Hammond.
Okay, thank you, Kim. ARB put out a manufacturer advisory correspondence to manufacturers in December of last year to indicate that the conditions in terms of how legacy engines that would be sold outside California and within California could obtain the clean idle label. And so there are provisions to allow that so that we can continue that and allow clean idle engines to be used outside of California. And so there are labels that could correspond to that, and that MAC would address it.
Thank you, Susan. Our next question comes from Richard Rakowski. How much does the formation of secondary PM from NOx inform your goal to reduce heavy-duty vehicle NOx emissions?
This whole temperature adjustment function, we know it's going to have an impact on the overall emissions from heavy-duty trucks in California. We haven't modified, in fact, we haven't done the analysis to see exactly what those numbers are. We will not be able to sort of provide that to you. We can show you the upper and the lower bounds, which is shown on this chart, but additional analysis on that is probably going to take more time to address. So I don't have a number that we could share with you at this
We would
time.
have a number. I'd like to add, I don't think we have a research division representative here with us, but the health benefits model are take into account these NOx emissions and the secondary PM formation. So in at least in our eyesore, the health benefits are based off of the secondary formation you're asking about here, Richard. The next question comes from Chris Riddington. I think the D rate schedule refers to the reduction in speed when a sensor and engine codes. Sorry. Specific question is regarding to over the road buses.
I'm sorry. Please send us. I don't understand what section of the regulations you're referring to. Please send us the regulatory citation, and then we can go ahead and take a look at it. I'm sorry. I just don't know what section or what mechanism you're referring to.
He's got about 4 questions here that all look like they're getting around this use of buses and SCRD rates and the various operational impacts that can happen when a vehicle gets into one of these situations where it needs repair.
Yeah, please send us the regulatory citation, just to make sure we're talking about the same thing.
But yeah, it's the inducement. So he's like, no one has read these questions out loud yet, right? We need to share these with everybody. So Chris Riddington says by the D rate schedule, he means the reduction in speed when a sensor or engine codes. A specific question is regarding to over the road buses.
Yeah, this may not be inducements, Kim. This may be something else. Because inducements is just for SCR. We would like to get more specific guidance from you in terms of what you're referring to before we can answer that question.
Okay, but we need to, for transparency, we need to make sure people know what the question is. So he said EPA adopted the D rate schedule for 2027 to effectively eliminate the possibility of a bus with passengers derating within 4 hours to 5 miles per hour and exposing passengers and the traveling public to catastrophic loss of life, bodily injuries, and property damage through rear-end collision. Would CARB review the 2027 safety issue and look at making this retroactive to all buses that have a D rate schedule that puts passengers at risk? He goes on through public comment. EPA discovered that most inducements are a result of defective sensors and or error codes generally unrelated to the items that EPA sought to induce a D rate schedule, such as exhaustion or of DEF fluid and a failed DEF pump. To summarize, the California Bus Association, speaking on behalf of California and the nation's bus companies, respectfully requests the California Air Resources Board to adopt the D rate schedule contained in US EPA's final rule for model year 2027 heavy-duty diesel engines by expanding the D rate schedule to all model years of heavy-duty diesel engines, thereby decreasing the potential for crash and injuring passengers and the traveling public. Okay, thank you for the comment and the request, and we will definitely be looking at all parts of EPA's Clean Truck Plan NOx rule, including their changes to inducements, which I think is what you're talking about, and we'll definitely be considering aligning, and thanks for your suggestion.
Thanks, Kim. Our next question comes from Phil. This is a follow-up on EPA has granted a longer inducement schedule to be implemented into an existing and new models. Does CARB recognize the dangers of derating vehicles to 5 miles per hour after 4 hours, specifically in regards to passenger transportation, such as motor coach operations? And Phil continues, from the EPA, motor tech operators submitted comments describing the greater sensitivity to any speed derate because much of the greater responsibility for carrying people safely to their intended destinations over long distances, including their role in emergency response and national defense operations. After consideration of these comments, we are allowing manufacturers to design and produce engines that will be installed on motor coaches with an alternative D rate schedule that starts at 65 miles per hour. D rate when a fault condition is first detected, steps down to 50 miles per hour after 80 hours, and concludes with a final D rate speed of 25 miles per hour after 180 hours of non-idle operation. The EPA EPA is defining motor coaches in 40 CFR 1036-801 to include buses that are designed to travel long distances with row seating of at least 30 passengers. This is intended to include charter services available to the public. Let me see here. I think the next question is from Tim French. So just to confirm, the 4.9 tons per day number is assuming all the heavy duty on highway VMT is at 5 degrees C, right?
Yes.
Yes. Okay, currently, I'm not seeing any questions, so I think we can move to our third presentation from Mitzi Magtoto to talk about California's GHG goals.
Thanks, Christian. So I'm Mitzi Magtoto, Air Resources Engineer, and today I will be discussing the last agenda item, Phase 3 GHG regulation designed to reduce CO2 emissions from heavy-duty on-road vehicles. So California has goals to combat climate change of 40% below 1990 emissions by 2030, then to meet the more aggressive target of 80% below 1990 emissions by 2050, require 60% renewables by 2030, and with the final target to achieve carbon neutrality by 2045 and a zero carbon electricity grid within the same time frame. So many strategic midterm targets and GHG regulations have been set along the way to help us reach these targets. Next slide, please. Now I will touch on the Phase 2 and 3 rulemakings timeline. Beginning on the left, in 2016, the federal agencies adopted Phase 2, and after a year and a half, CARB largely aligned with these federal Phase 2 standards. US EPA has been working on the third phase of federal GHG emission standards and is planning to release the proposed Phase 3 standards this month and the final rule in December. Next slide, please. I will provide some nationwide highlights from 2022 on this and the following slide. In August 2022, President Biden signed the Inflation Reduction Act, or IRA, into law, marking the most significant action Congress has taken on clean energy and climate change in the nation's history. The IRA, built on President Biden's bipartisan infrastructure law, includes a tax credit for qualifying electric vehicles of up to $40,000 for heavy-duty vehicles. In November 2022, the government of Arab Republic of Egypt hosted the 2022 United Nations Climate Change Conference, or the 27th Conference of Parties of the United Nations Framework Convention on Climate Change, or COP27. The conference is held annually since the first United Nations Climate Agreement in 1992. It is used by governments from around the world to limit global temperature rises and adapt to impacts associated with climate change. At COP27, U.S. Secretary of Energy signed a global memorandum of understanding to advance heavy-duty ZEV sales in the U.S., requiring 30% of new commercial delivery vehicles, buses, and trucks to be zero emission by 2030 and 100% by 2040. Next slide, please. OEMs are projecting significant heavy-duty ZEV sales by 2030 and making commitments for full decarbonization by 2040. Navistar's executives expect 50% heavy-duty ZEV sales by 2030 and 100% EV or fossil-free by 2040. Daimler Truck said ZEVs should make up 60% of its sales by 2030 and 100% of sales by 2040. Volvo Trucks has higher targets of 70% of all new trucks sold will be battery or fuel cell electric in 2030 and 100% by 2040. PACCAR predicts EV production in the US will ramp up exponentially in the coming years with 100% by 2040. Many independent studies are also forecasting large heavy-duty ZEV penetration rates nationwide, in particular due to IRA. A recent modeling effort by International Council on Clean Transportation and Energy Innovation forecasts that IRA will cause heavy-duty ZEV sales to increase significantly, from 10% sales for the business as usual case to roughly 25% of sales in 2030 with the IRA in place. This concludes the GHG presentation. Now I'll pass it back to Christian for any questions.
Okay, we're going to open up the questions if there's any comments on the GHG goals. While we wait for more questions, we have one in for the previous topics from Matt Spears. So thank you for replying to my question earlier regarding the potential Omnibus legacy engine revisions. We very much appreciate CARB working with stakeholders to address 2024 to 2025 Omnibus product availability and cost issues. We remain concerned that the latest we have heard will not fully address those issues, especially for medium heavy duty consumers in California and in Oregon. We look forward to engaging more with CARB to resolve remaining issues in the way that would still deliver Omnibus emission reductions. Would you please acknowledge this in the Q&A reply? Oh, thank you, Matt. We have a question from Barbara Chance. Is CARB planning to follow EPA's phase 3 rule?
To answer that question, so this is Mitzi Mankoto. So after US EPA released their notice of proposal, which are aiming to release it this month, CARB staff will review the proposal and consider any alignment.
Okay. Benjamin Meng asked to go back to slide 29 here. And just thanks for the presentation.
And just to clarify, these slides are posted on our website, so anyone can grab them and download them and look at them later at their leisure.
Thanks, Kim. We have a question coming in from Sean Coca. Are vehicles that conform to EPA standards still be able to operate in California, even if they do not meet CARB's low NOx rules?
So let me see if I can take a stab at that. So the omnibus regulation impacts what is sold as a new engine in California, and you want to register that vehicle as a new vehicle in California. If you purchased your truck from out of state and you registered it out of state, when you come into California, I mean, you can drive them to California. There's some rules that we have, for example, the idling rule that would still apply when you drive them to California. Bill, anything else I'm missing here? You help me out. Or Daniel, I think that the idling is the only one that comes to my mind. If you have a vehicle that doesn't have a clean idle label, California clean idle label in it, even if you bought it from out of state, you come here to California, you will still be subject to our idling rule.
I know we've been trying to avoid getting into the advanced clean fleets discussion in this particular workshop, but I do note that the advanced clean fleets team has workshopped an aspect of their rule that gets at the idea of trying to do an end run around the California Omnibus by just bringing in out-of-state purchase trucks during the whatever period that were not aligned with the federal program. So that they are considering some things that would probably apply the most during the 24 to 26 period where we have a program and the federal government doesn't. And then we'll we'll see what happens after 27. But it is a consideration, and I think Paul mentioned that new vehicles have to be California certified, and there's a definition of that on the basis of mileage, and the clean idle, and then we're looking at it from the fleet rule side of trying to make sure that there isn't that kind of leakage.
And what about the inspection and maintenance? Can Kim comment on that? Probably. It applies to out of state vehicles, I guess.
That applies to everybody.
It
Everybody,
does.
yeah.
Any truck operating on California roads. Yep. But I guess maybe just stepping back a little bit, like part of the reason we're even having this workshop and that we're so closely scrutinizing the federal NOx standards is because federally certified trucks do operate here and are a very important part of our emissions inventory. So if federal trucks just weren't even allowed across the border, maybe we wouldn't care so much about the federal standards.
Yeah, I mean, we get them in the used market, and they're driven transiently through California. So there's about half of our NOx right now from heavy duty trucks is from federally certified trucks, and about the other half is California certified. So it's a big piece of our truck inventory.
Thanks. We have a question from Steve Cranington. With the new EPA recommendations with D-rate timing, will CARB allow it? Our cargo is quite different with motor coaches. Our freight could die. Example, D-rate in Death Valley on an extended tour.
I could just reiterate, we'll definitely look closely at the new D-rate changes, and we actually worked closely with EPA as they were developing those, and so we'll definitely be looking at that as we figure out where we're aligning with EPA. But thank you for commenting and making your opinions clear here. And then, yeah, Bill McGavern confirmed, yep, out-of-state trucks are subject to I&M, just like in-state trucks. And just a time check, we do have the Truck and Engine Manufacturers Association requested some time to present some slides. So we're going to shut down the comments here at 1:45 and give them a chance to present their slides. Kevin Creighton is asking how, okay, it looks like he's from maybe a motor coach association, is asking how can we achieve the electric proposed, and I think he's referring to the Advanced Clean Fleet rulemaking, which is kind of outside the scope of today's discussion, but I would refer him that rulemaking will be considered at our board's April hearing, so there'll be a lot more discussion on that there. Phil asked, would CARB be willing to schedule a discussion with the California Bus Association and United Motor Coach Association on potential alignment? And yes, absolutely. We would love to talk to you. And that wasn't really, obviously, it wasn't really what we were thinking we'd focus on here today, but we would be very, very happy to meet personally with you guys and hear out your concerns and everything in detail. Okay, Brent Danielson asks, as a general question, why are over-the-road motor coaches, which are designed to carry 56 passengers and take individual passenger cars off the road, lumped in with heavy-duty trucks? Also, considering that the yearly coach market is probably 1/300th the size of the truck market in California, the overall NOx contribution of a motor coach is a very small fraction of what the highway truck market generates. Yeah, so when we look at engines and like what standards are technically feasible and cost effective, often the engines that go into truck or buses and motor coaches are, the same or very similar to the engines that go into heavy duty trucks. So that's why when we're talking engine standards, those same engine standards often apply to buses and to trucks. And we get that, if you dice up the emissions inventory into lots of little pieces, any one piece is very small, but in order to address California's severe air quality challenges, we kind of have to look at every single piece. And so that's why we can't just say, oh, we're not going to control emissions from motor coaches because they're small. If you did that for everything, suddenly you'd have no emission sources left to control. Okay, but we now have hit 1:45. And so let's give, I think it's going to be Steve Berry from EMA a chance to share his thoughts.
Great, thank you, Kim, and thanks to to staff for organizing this discussion and giving us a chance to share some of our thoughts. If you can go to the next one, please, Christian. So we're going to focus our comments on the two primary issues that you've raised here today, the NOx compliance allowance and the cold ambient temperature standard adjustment, NOx standard adjustment. Next slide, please. So first we'll take the NOx compliance allowance. The graph at the right is a summary of 154 engine families from EPA's certification database. To the right of the graph are the, say, 4 grams per horsepower hour. That represents the US 98 standard. And the standards become more and more stringent over time as you work to the left side of the graph. You can see in the blue line that the margin, the difference between where manufacturers certify the product and the prevailing standard, has, of course, had to slowly decrease over time. But when assessed as a percentage of the standard, it's increased considerably from something in the range of, if you look at the right scale, 7% up to US 10 levels today, where the margin is about 35%. So this demand for margin is just a further progression and the next step as we move to 2024, 2027, these latest low NOx engine technologies, representing the demand that's there to protect for a delta between what the manufacturer certifies to and what the prevailing standard is. And that's in part to deal with variabilities in the field, real world variabilities. So if you go to the next slide, then please, Christian. So EMA started a year and a half ago or so to try to quantify the magnitude of the margin requirement. And the table here is something we put together where we identified the various sources of variability, the kind of impact they have as a matter of biasing tailpipe NOx emissions slightly higher or increasing the variability from one unit to the next. EPA used a similar technique, very similar statistical approach, very much informed by Southwest Research, CARB's Omnibus research partner, to come up with their own assessment of the variability to be expected in the field. And this is all about the variability, the difference between what you can demonstrate in the laboratory with a demonstration engine and the realities of the real world that the laboratory doesn't have to deal with. So you can see EPA came up with their 0.015 gram per horsepower hour. They may have left out a couple of items like packaging challenges on certain vehicles. We've got new data coming out now from CRC where fuels are shown to have perhaps a greater effect than the 1 milligram that EPA has assumed here. So more work to be done perhaps, but we appreciate that EPA has done the right thing to consider this in a technical way and to assign an appropriate allowance. Next slide, please. So taking the cold adjustment now, Shun has already explained the way this test was conducted. At the right graph, you see that the temperature for the CARB Southern route, this is one of the popular routes that CARB uses to test vehicles in California, was simulated in the engine laboratory with ambient temperatures in the range of 5 to 8 degrees C. The result was, under those conditions, the bin2 emissions was increased by about 40 milligrams over typical over similar tests when run under nominal ambient conditions in the test cell, 25 degrees C. So this was a core basis for EPA's evaluation. But I think it's important also to look at the next slide. It was mentioned that there's a convective airflow across the aftertreatment. This low load cycle was run at about 6 degrees C, 5 to 6 degrees C, and the ambient airflow across the aftertreatment on average during the entire cycle was about 3.5 miles per hour. That's about the speed at which an individual takes a stroll in the park. So this is not high velocity wind effects that are somehow influencing the data in a significant way. You might figure that the convective aspect was rather minor in this particular test. Yet the cycle NOx, it was increased to some 60, 70 milligrams for the cycle. And importantly, if you hit the next one, please, Christian, the bin 2 emissions was increased by about 50 to 70 milligrams, depending upon how many preconditioning tests were run to fill the after treatment with ammonia prior to the start of the test. EPA's allowance provides only for a maximum of 44 milligrams, and that's without any preconditioning be allowed. So this data might lead to the question as to whether EPA provided enough of an ambient, cold ambient adjustment. And this cycle, the low load cycle, is certainly viewed as a legitimate cycle. It's one of CARB's new certification cycles that EPA in fact adopted. So this is real world operation, and these are the real kind of differences that resulted. Next slide, please. So if you look at the plot of the blended bin 2 standard, the green line there, which applies down to 25C, and then the blue line projects upward to show the impact of the cold ambient adjustment. Compare that to CARB's bin 3 standards, which the lower red dashed line is for vehicles having less than 435,000 miles. The upper line for those having more than 435,000 miles. And if you click one more, please. And then these are the bin 2 standards, the bin 2 standard for less than 435 in the lower black line, the upper black line for vehicles having more than 435,000 miles. You can see that there's concern about stringency of the EPA reg. It, in fact, in ways is more stringent than the CARB reg in the end. One more click, please, Christian. The LLC data we were just talking about at 6 degrees C would fall there at 90 milligrams. So the ambient adjustment EPA has provided seems appropriate. CARB's bin 3 standard for this high mileage engine, bin 2 standard for the high mileage engine, this would pass easily under CARB's standard. Next slide, please. So we saw a similar graph. Be good to compare data, and we're glad to share any of the data we have. A former engineer from West Virginia University worked with us to acquire National Weather Service data for the Ontario airport near Riverside. And this data represents the ambient temperature excursions over the course of the year from January on the left all the way through December on the right, like similar to the graph that you saw earlier from CARB. The dotted line, black line, is the 8 a.m. temperature on average, and the upper red dash line is the peak temperature during the course of the day. So from this hourly data averaged over 15 years, you can determine what the typical time-weighted ambient temperature would be for the throughout the year. And if you click once, please, Christian, it's that weighted ambient temperature profile that is used to calculate the NOx adjustment factor EPA has provided for in cold ambient. And you can see the adjustment factor is 0 in the months from June through October, even though there is operation below 25C, the way the time-weighted average works, there is no adjustment applied. And the impact goes as high as perhaps 20 milligrams, but that you don't reach those kinds of levels until you get to the colder months of the winter. Next slide, please. And there was some data submitted to the docket, and we saw some of it today, looking at the tailpipe NOx levels of US 10 compliant engines in cold ambient temperatures and conclusions that there was no measurable impact to NOx. But that's a very different engine design and aftertreatment design. The EPA 2027 design, according to the stage 3 technology, depends on very high levels, some 99% and higher SCR efficiency levels. So the tailpipe NOx is going to be much more sensitive to small deviations in exhaust temperature, especially for high mileage catalysts. And it's worth noting that the stage 3 test was at some 800,000 mile equivalent aging on the aftertreatment system, whereas the tests that were referenced by CARB are much lower mileage vehicles. So the degradation to the SCR system is much less, and much less sensitivity to these small differences in ambient temperature and exhaust temperature. Next slide, please. So to wrap up, the compliance allowance is appropriate, completely in line with EMA's own thinking and a statistically valid approach to accounting for the variabilities, the sources of variability that occur in the real world that are not part of an engine demonstration project. In the case of the EPA CTP rule or the CARB Omnibus regulation, we encouraged CARB, we encouraged EPA on multiple occasions to put this hardware into a vehicle and to test it in the real world so that we could have a much better assessment of cold ambient temperature. But project timing and perhaps funding and resources didn't permit that, unfortunately. The cold ambient temperature testing over the vehicle LLC showed significant increase, much more than provided for by EPA's cold ambient temperature standard adjustment. And that's despite the fact that the convective airflow effects were very low, and the fact that preconditioning had been applied during that testing, whereas manufacturers don't get the opportunity to use preconditioning when conducting an in-use test. By this assessment, and we're glad to share any of the data that we have here today with you to compare to the data that you acquired regarding cold ambient temperature excursions and characteristics. But the temperature adjustment won't play a significant role in the South Coast for most parts of the California during the summer months where the ozone is of most concern. And it was mentioned that after the cold ambient temperature testing was done, that the EMA project scope did not include an investigation of these measures. In fact, Southwest Research provided a number of recovery alternatives to reduce the NOx to some degree, or perhaps completely, all of which, of course, came at the expense of additional hardware and certainly CO2 emissions. EPA moved forward without accepting, making the judgment that the CO2 penalty was not worth the investment to recover the NOx in this case, though you should certainly talk directly to them, and I'm sure you have, as to the basis for that judgment call. That's all I have. Thank you.
Hey, thanks so much.
Thank you, Steve.
Really glad we had time for your comments, Steve. Just to note, of course, we're not only concerned about NOx because of ozone, which is, generally like a summer high temperature problem, right? We're concerned about NOx because of secondary PM, which, as Christian noted, was where we got all the health benefits we estimated for our whole program. And then also, not all methods for keeping things warm require additional fuel, right? There's insulation, there's other things you can do to keep things warm, even if it's really cold outside. Okay, so I just want to make sure that we let people's comments be heard here. Eric Feely, who I think is from Oregon DEQ, says, CARB staff, thank you for the effort that you put into this presentation. Your methodical walkthrough has been very educational, especially temperature information and comparisons. Well, you're welcome, Eric. Okay, Kevin Creighton said, any reality would help on the new D-rate rule for motor coaches. There aren't motor coaches in the Bay Area. Motor coaches are due to tourism from state to state. And then Phil also, I think, talking about motor coaches, says, we really appreciate your willingness to discuss this. Yeah, totally. Reach out to me or reach out to Paul and Nani, and we were happy to sit down and talk with the motor coach folks in more detail on their concerns. Oh, interesting. Richard Brakowski asks, will the EMA slides be made public by ARB? We were not planning on posting those. But if anyone, okay, so if anyone wants them, EMA did give us the slides so we can show them. So if anyone wants them, feel free to ping us or ping EMA directly, and we're happy to email them. Okay, and yeah, so I will type my email address into the chat here. And thank you so much. Really appreciate everyone taking time to talk with us and comment and share their ideas on a Friday, especially.
Thank you.